So, okay. Okay. So, very good afternoon, everyone. Um, uh, yeah, just give me a second, please. So, good afternoon. Uh, the topic or title of my talk today, as you can see in the slide, Artificial Intelligence in Research and Modern Insights. So, as already I have been introduced, so there is no requirement that I introduce myself once again. But at this moment, I would like to start by congratulating uh, the organizers for taking up this challenge of organizing an FDP on such a challenging topic, artificial intelligence in research, or there are various other aspects of artificial intelligence. The reason I'm saying this is a challenging thing is uh, because of the vastness of this topic. Because if you see, there are a lot many people working in this particular field called artificial intelligence. You have been hearing talks from computer background people, from physics background. I am in particular from physics background. There are even people from chemistry background, mathematics background. So this field actually has emerged by the contribution of so many people with so many ideas and algorithms that it is really not constrained to anything, and rather it demands the attention of a larger group of people. And already, as I have learned, that there are in this particular FDP also we have vast, diversified audience. So looking into this aspect, like diversity of the audience and also the vastness of this topic, it often becomes a little difficult to choose an appropriate title. So, however, I have just chosen this because many of us are researchers or willing to do research. So, in future, how artificial intelligence will be used in research, or how will it shape the modern research? What are the current scenarios going on? Although this field is still evolving with the new and newer concepts. So let us just go in a brief way. I have tried not to go into much technicalities, rather to go like more on like a sort of, a popular talk on artificial intelligence. So I hope you would enjoy this talk. So let us start with the outline of my talk. I'll be dividing this talk into four main sections. One is introduction, then second, AI in modern research. Followed by that, I'll discuss a little bit of PIN. PIN means as you can see here, the physics-informed neural network. And followed by that, we would like to conclude, where we will give just the summary of AI, its futures, possibilities, etc. Now, let us go into the introduction part. But before I start, let me begin with good news. And what is the good news? Good news is that there are two people who have recently been awarded the Nobel Prize. One is our John Hopfield, another is Geoffrey Hinton. Now, both of these people, they have worked on artificial intelligence. Actually, they have been working on these particular sectors for very many years. And they are basically from physics background, or they have applied the concepts of physics into the concepts of artificial intelligence. So here I have just very briefly given their work for which they have obtained the Nobel Prize. Geoffrey Hinton, in particular, he invented a method that can autonomously find the properties in a data. So what he did in 1983 and 85, you can see this duration. So this duration is very important. So 1983, 1985. So he used the tools from statistical physics to create the Boltzmann machine, which can learn to recognize the characteristic element in a set of data. And quite contrary to that, this guy, John Hopfield, he also did something of that sort, and also his invention helped in image analysis. So both of their discoveries or inventions that helped the image recognition processes, and for which they have been recognized by the Nobel Academy, and this year they have been conferred this award mainly for their development of algorithm on artificial intelligence. So these top lines are basically from the Nobel Academy, which says the Nobel Prize in Physics 2024 was awarded jointly to John Hopfield and Geoffrey Hinton for foundational discoveries and inventions that enable machine learning with artificial neural networks. So in my talk today, we will talk about what is machine learning, what is artificial neural network, how can we really solve a particular problem with example using the artificial neural networks and how exactly they build those connections. Okay. However, I'll not go into the technicalities as already I have repeated. I will go in a very brief way and rather in a sense, in a popular science lecture kind of way. Now, what would be a definition of AI? Now, already you have attended 3 sessions prior to this talk, so hopefully many other speakers have already given you this definition. Artificial intelligence is a technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy. You see, there are many words in this particular definition, and this definition has been framed by IBM, International Business Machines, this company. They are actually taking a lead role in the development of this technology called artificial intelligence. So what basically on a gross scale we can understand is that this is a technology which is supposed to learn like we learn, the humans learn. Now, how do we learn? We learn by the process of doing through our experiences. We do something, commit a mistake, we learn from the mistake, we rectify the mistake, and again do it. Again, we commit some kind of a mistake. Like that, we keep on learning. You remember when we were kids and we were given the summation problems or subtraction problem, many a times we used to do wrongly. I mean, we used to commit errors. Now, whenever we committed error, there was a teacher who used to come say, no, this is the step where you have done it wrong. So you should actually follow this particular procedure and this should be the outcome. So once the outcome is given to us, once we know that, okay, 2 plus 3 should be 5. So how possible that I will get a 4 or a 2 or something other numbers? It should always be 5. So through that mistake, if I get something else, I would know that, okay, I have committed an error. So through that mistake, I would learn, I would concentrate more on getting an exact solution. And likewise, I would develop a learning procedure and I would come to a state when there will be no longer errors. Rather, if somebody gives me a summation problem, I would instantaneously be able to solve it. Now, if somebody asks, what is 2 plus 3? We normally, you see, we instantaneously say it is 5. Do we have to count like 1 plus 1 plus there are 3 ones? So if you count on those individual ones and you get to 5. No, we do not know. We do not do it now, no longer. So we rather instantaneously, we are able to give answers. Now, so artificial intelligence is something where we would like to make those machines act like that. Now, if we do that, what could be the characteristics of artificial intelligence is that applications and devices that are powered by AI, they should be able to see and identify objects like we see. Suppose we see a goat or we see a dog. We instantaneously say this is a dog, this is a goat. So our human mind is trained in that order since our childhood, through which we can say, okay, this is something else, this is something else. Now, again, something if it is given us to us which we have never seen, then again we have to learn on that, isn't it? So similarly, the case of a machine, the machines should be able to see and identify objects. They should be able to respond to human languages like we talk. It should be able to interact with us in the same language. It should be able to learn from new information. As you can see over here, any new information which is given to the machine, it should be able to learn that. Then provide the recommendations. For example, now if you have visited a hotel, somebody asks, how is that hotel? You should be able to recommend it, isn't it? Because, okay, I have gone there and I find it nice rooms, nice toiletries, a nice ambience, such as such. So based on certain parameters, we recommend, okay, this hotel is good, that hotel is little not up to the mark, something like that. So machines should also be able to recommend. then they should act independently without the requirement of human intervention. So without the intervention of humans, they should be able to act independently. For example, if you ask the machine something, it should be able to come up with an answer, of course, within its bounds, but it should give you an appropriate answer. So then I would say that, okay, the machine is acting independently. Now, question is, have we reached to that state, or is it at all possible? Now, the current developments in technology seems that we are going in the right path, and there are very many items, or there are very many programs which are actually giving us that sort of, that sort of an answer. For example, let us see the first case over here. As you can see, there are some numbers which are handwritten. Now, suppose I write something 1, 2, 3, 4. These are handwritten numbers. Now, if you give it to the machine, there are nowadays programs which will read those numbers and would be able to give you the identification as 1, as 2, as 3, like that. Not only that, even if you give a little blurred image of an object, if the computer or the machine has sufficiently learned it, then it should be able to judge and give you an answer that, yes, this is a dog, that's a goat, that's a cat, something like that. Not only that, next we have respond to human languages. Now see, we have a lot of chatbots nowadays. For example, if you book your gas cylinder, through WhatsApp or through other such IVRS systems, there is somebody who is actually communicating with you, which is talking with you. So what is that? That is nothing but a bot. So whatever you answer, he is also, or I mean, like the machine is also capable of giving you the responses accordingly. Not only that, we are nowadays capable of translating. Like Google Translate is a very good software where you can translate any language. Almost like there are nowadays, I have not counted, but there are many languages in between which you can translate. And this is a very good software. The more translations it is doing and more feedbacks it is receiving, based on that, it is learning new and newer words, newer types of translations, and it's getting better and better day by day. So that's actually a characteristics of AI. If it is AI, artificial intelligence, it must be able to learn. Then we have chatbots, like not only chatbots, like Gemini. Nowadays, if you search something on a Google toolbar, the first answer comes from this particular thing, Google Gemini. So it's an artificial intelligence answer, and following that, you will get all sorts of websites or search bars through which you can get your answer. Then you have Quillbot, which is a good paraphrasing tool. For example, you write something in English, and you want that my English is not very good, or I'm kind of new to English, or new to some other kind of language. I have not seen such a thing for other languages, but for English, it is available, paraphrasing tools. Now you can give it to Quillbot, it will paraphrase it for you, depending on certain qualities, like whether you want a fluent answer, you want a standard answer, you want an academic answer, how you want to modify your English sentence. So that's how it converts your words or sentences and gives you a really very beautiful sentences, along with the option to choose some of the phrases. So how this is possible? In the background, you have the AI technology. Then we also have the self-driving cars. The self-driving cars are those cars where you do not need to drive. You just give the input location, and it will go. It will take you to that particular location. Now, we are there are many self-driving cars developed by, like, Uber also has, Tesla recently have developed, Google also is trying. So the technology may not be very up to the mark yet, but or commercially not possible right now, but I don't see it far away in time when self-driving cars will be a reality and in our day-to-day life in our streets. And the most important thing which we are actually right now seeing is the recommendation. Now, this is a picture or image from Amazon Prime. Suppose you are a viewer and you have liked movies or some shows of a particular kind. Now, suppose there is a recently, Panchayat, which was, very famous and was in hype. Now, suppose I am a person who has given 5-star rating to Panchayat, and I am the same person who has given a 5-star rating to something else, which is quite like Panchayat, which has village sense in it, little, little vernacular languages into the script. So the AI automatically understands my choice, that I'm a person who loves this sort of a thing. So what it will do, it will show me or pop me up those movies or those shows which are having those kind of characteristics. Not only that, suppose I am a person of that sort and I have not able to see it. Suppose there are 10,000 movies. It's not possible for me to rate all of them. Then how would it actually give recommendation? It would give recommendation based on my feedback and also the feedback from other viewers whose recommendations or whose feedbacks are quite similar to me. So through that data analysis, it can come up with an answer. Okay, those many, suppose there is a person B whose choices are quite like me, and he has liked a particular movie and I have not seen it at all, I have not given a feedback at all, then AI would automatically recommend that movie to me, thinking that because my choices are quite similar to the choices of the person B, hopefully, since B likes that movie, I may also like that movie. That's how these recommender algorithms work. And it, of course, the data has to be correct. So that is why nowadays you see all these platforms like Amazon, you have any kind of websites which depend on customer related things or which deal with people. They actually nowadays, look for such feedbacks so that they can experience or they can, serve you better. So AI is basically something which learns from the experience. Okay. Now, if we look at the hierarchy of the AI development, now in 1950s, you see there was artificial intelligence. This was conceptualized basically. How it was conceptualized, that is also a very beautiful story. I will come to that in my next couple of slides. Then came somewhere around 1980s, the development of machine learning. And following that, deep learning, which is relatively quite new because in somewhere 2010 around, but there are also papers like in 2006 or 2004 where people have talked about this particular development, deep learning. So I have written it 2010s around. So tens means not necessarily that it has developed in 2010, but somewhere in that decade. Then 2020, we have seen the marvelous development where we are currently in the era of generative AI. Generative AI means it's a deep learning models that can create original contents. Now you must have heard about ChatGPT. You must have heard about those paraphrasing tools, which I have already talked about. There, it can create a new content. Suppose not only that, in your WhatsApp, there is a small circle. If you have noticed, it is written Meta. So if you just click it and I have just tested it. For example, you just give it a what is cos of A plus B and leave it just like that. It will come up with the answer. Sine of A plus B. What is sine 90 plus theta? It comes up with all those question answers. You can ask it anything. Suppose you, for example, there's this particular image which I have incorporated here. It has also been created using that. I have just said, create an image where a person will be interacting with the machine, something like that. I have given a statement and it has come up with this particular thing. Here, there is a logo also. You can see this is created with Meta. So like that, you can really chat or you can really give instruction and this can give us the original content. So this is actually known as the generative AI. Now, if you see who is within whom, the artificial intelligence is really the broad spectrum topic within which as a subset remains the machine learning. And again, as a subset of machine learning, there is deep learning. Okay, so one is the subset of the other. Artificial intelligence, the broader one. Second is machine learning. Then third is the innermost thing is the deep learning. Now, going to the history of evolution of AI, somewhere around 1940s and 50s, you have this person named Alan Turing. He was a British mathematician and rather a theoretical computer scientist who had his great impact into this, Second World War. Because Second World War, Germans developed a machine called Enigma machine. Enigma machine was mainly built to encode some of the messages so that the enemy party, they cannot decode it. But this guy, Alan Turing, he developed some algorithms back then through which they could decode the signals received from the Enigma machine. And Enigma machine, there are many videos you can go through in YouTube and elsewhere. It is a very complicated machine. It's really hard to get a sense how can a person decode such an encoded task. But yes, really, Alan Turing could do it. Then somewhere around 1950s, he came up with a theoretical or a philosophical, you can say rather, philosophical thought experiment, which he calls it nowadays, we also know it like that, Turing test. What he said in Turing test, I can just show you his original paper. This is the original paper. It was published in this journal called Mind, a quarterly review in 1950, October, in the month of October. We are now in November, the previous month, October. So we have almost completed how many years? 1950s to around 70, 74 year of this particular paper. He calls it the imitation game. If you remember, there is also a movie nowadays, the imitation game. I have not gone through, provided many of you must have seen that movie. Yeah, so in that particular imitation game, what he says, can machines think? You can go through these early statements. You see what he says, I propose to consider the question, can machines think? This should begin with the definition of the meaning of the terms machine and think. So what he says is that, can machines think? And he gives us an thought experiment. Like suppose there is a person C who is an examiner, you can say. And there is a person B and there is a person A. Now A, let's consider that A is a man and B is woman. Now what happens? This person C, there is, his gender is irrespective in this experiment. C can ask questions to B and A in terms of written questions. Got it? Now, he will also receive a written reply. Now, based on the reply, he needs to judge whether B is man or woman, or A is man or woman, or any other trait you can give, for example, whether B has long hair or A has long hair, something like that. Any of the trait which you can give. So particular person C should be able to distinguish it. Now, Alan Turing says, what if I replace this man by a machine? And the machine interacts with C in terms of writing. Now, the written replies that should come from A to C should have certain qualities through which we can say that yes, the machine is interacting with C. And in that case, we can say that yes, machines can really think. So it is actually a long paper. It goes out like a conversation between among these three people. He puts up some of the questions. Again, he also puts up some of the objections. It's a long paper. It's almost 28 pages of paper. You can go through it. It's freely available over internet. But at that time, there was no such thing. It was just a philosophical idea. He just framed it. So that's why the first conceptualization of such a chatbot, you see, long back in 1940s and 50s, he could visualize this particular thing. Then came to the era of 1960s and 80s, where this dream was made possible through the first development of a chatbot called Eliza. And I guess in this particular period, there was one more chatbot which came. That's name is Perry, if I'm not wrong. I'm not quite sure about it. It's Perry or something else. Yeah. So Eliza was the first chatbot which used to, simulate like human conversation. So as I have highlighted over here, Eliza, as you can see, is a natural language processing computer. It was developed from 1964 to 67 at MIT by Joseph Weizenbaum. So it was the first of its kind in chatbot, but it was not very accurate. But anyway, looking at this era, 1964, 67, and also thinking in terms of the capacity of the machines, the computers, it seems quite reasonable that at least the machine was able to answer something. Then comes the winter period for AI. Somewhere around 1980s, the funding went down. People were not that interested in AI. Governments were not funding these projects anymore. So it was really a winter period. But again, somewhere around 1990s, this period, 1980s to 1990s, we saw emergence of the machine learning. So once the machine learning came, we developed newer and newer technologies of learning algorithms such that many of the tasks in scientific activities got eased out. And this was the time when IBM developed a Deep Blue computer, supercomputer basically, that defeated the chess champion Gary Kasparov. So you remember in those times, these type of news were coming into flashes, like this computer has defeated a chess champion or something like that. And IBM was really hard on these machines. So that was a time when people again started gaining confidence. Okay, there may be a situation when AI really can give us something. Now, but it was all scattered at the time. I mean, there was nothing like artificial intelligence as we have under one umbrella. We are talking, we are discussing, or holding up conferences like this. There was nothing that sort. It was a little scattered, mostly confined to specific community. Then came the era of 2000s, where you see the genesis of generative AI started. See here also, once again, this particular name is coming, Geoffrey Hinton, propelling deep learning into the limelight, steering AI towards relentless growth. So Geoffrey Hinton is the same person who has received the Nobel Prize this year in physics. So he actually took out this concept of statistical physics and applied, into this deep learning concepts, how neural networks may come into action. What is the concept of artificial neural network? Something like that. Now, in 2010 came the rise of AI with the enhancement of AI's language skills. The natural language processing softwares were developed. Then also we had IBM Watson, which owned this Jeopardy quiz competition. This is basically the IBM's Watson computer, supercomputer rather. And Jeopardy is basically a quiz competition. Quiz competition is a little bit not quiz like what is the name of this, what is the name of that. No, nothing like that. It is something like they will give you some hints, and through that hint you have to guess what is the thing or what is the subject about which this guesses are made. So based upon those hints, IBM Watson machine was completely able to say the answers, and it not only participated in this quiz competition but also won that particular competition. And yeah, it received quite a $1 million, yes. And then came this era of 2020, when now we are quite familiar with these terms like Chat GPT, Google's Bard, Microsoft's Bing AI, and at the same time we also have Google's Gemini nowadays, giving us answers to many of our questions. The Facebook, Meta, all these things, Alexa. These are all based on this AI technology. And so we are also now growing on accessibility and reliability of information. Now, if you just search across the internet, you will get a lot and lot of information on AI developments. Okay, so this was a brief history of AI. Now coming to the future pros and cons of AI. Of course, the pros, there are many points on pros. I have highlighted some of them. One is automation. Automation would lead us to, enhanced, enhanced focus onto whatever we really want to do, and also bulk production, because once things are automated, you can really produce in a bulk number. Then reduced error. So once we calculate something through our hand, there is a possibility of error. And if it is given to the machine, definitely it will be fast and with less or minimized error. Improved decision-making, complex problem solving. So the fourth one is really interested is of interest to the physics community, or you can say to the scientific community in broad, because we now are facing the simple problems are almost like we have solved them. We now understand the complex problems. Complex problems, for example, You think of a nation like India, such a big nation, or China, where we have people of many different tastes, many different things. Now, if you want to launch a product, now what could be the possibility that this product will be, accepted into the community? In which area there will be a higher probability of selling? These are some of the questions which are now of importance to the market community. If you go into the stock market, what is the probability that a stock price will go up or the market would go up looking into the previous trends? If you think about the geographical situations, whether there is a possibility of an earthquake happening, looking into the previous data, what is the possibility that a big event, some kind of avalanche event will happen? These are some of the complex problems which involves a lot of agents, and these are typically sometimes known as agent-based modeling, because here every agent is a participant to this problem. For example, if I launch an opinion into the society, how this opinion will travel, or how many of the people will accept to that opinion. So that will depend on the personal choices of those people and the nature of those people. So every person in the society will contribute to that opinion, and he or she will also have a fair share of that opinion. And based on that, we can say that, okay, there is a gross opinion in this sector of the society for that particular problem or against that particular problem, something like that. So these are some of the complex problems. And the physics community or the scientific communities nowadays seems to be very interested in this type of problem solving. Okay. Then what are the cons? Definitely, if there are pros, there will be cons. Job displacement. AI, once it is given promotion to a large extent, it will reduce some of the jobs from the market. But I don't see it as a scarcity of jobs. I see it as an enhancement, because if some of the regular things which can be done by machines, we humans can, give our time more into the more creative things. So that's how I perceive it. But there are other perceptions of this particular topic. So of course, everybody has its own point of view in this. Then privacy concerns. Of course, this is really a concerning thing, because once we share, nowadays we almost share everything, and we do not know also, because anytime, you install an app, it asks you for a permission, and you really do not go through the contract note, what is written in that. So we almost give permissions to share all our data, and we share everything, birthday, even our Aadhaar number, PAN number, everything. So we really are no longer in private mode. We are already running in a public mode. So all those softwares know a lot many details about us. So privacy is certainly a concern, because AI works on data. Without data, AI cannot work. So as many data it receives, that much accurate result it will give. So that is why those companies or those machines which rely on AI technology, it must collect data. So that is why. Then comes ethical concerns, because who knows? There may be some good people who are really, working for the beneficial side of the technology. There will be some other people who will work on the black side of this technology. So this data which we are sharing, definitely that will infringe our own privacy. And not only that, uh, you know nowadays you see, AI can also write poems. So once we are the editors of a journal or something like that, how would we really differentiate which one is human written creativity, which one is machine written creativity? So it's becoming difficult day by day. Then again, cost. AI-enabled machines can be expensive, but cost is also not of concerns, because any technology, whenever it was first developed, it remains costly. Later on, with the emergence of time, it will definitely, the cost will come down. But I'm really concerned with, if you tell me personally, I'm concerned with privacy and the ethical issues. These two, I do not know exactly right now how people will resolve, but yes, those are threats. Then AI in modern research. In modern research, basically any kind of research, not only modern research, what are the topics which are of importance to us? Data, data analysis, modeling, and model analysis. Now, this artificial intelligence or machine learning algorithms work on the data. So if you give them appropriate input data, they can really work on the data, analyze the data, and not only that, it can build up newer and newer models. Once the model is prepared, it can also give you the answers of your queries throughout that model. Now, let us just come to some of the examples. For example, uh, this uh, is a newer development from our Institute for Plasma Research, where people have developed a software called Deep CXR. This is basically developed by the multidisciplinary research division, MRD, of IPR. Now they have taken many samples of X-rays so that they can detect which samples of X-ray has the TB. So if there is a tuberculosis of a particular patient, then throughout the software, just looking at this X-ray image, it can say. So they actually did this research in collaboration with ICMR, Indian Council of Medical Research. So they took almost like 1 lakh samples of X-rays. They trained those samples through image processing. And they came up with in which X-rays there was a TB, like they trained their model accordingly. And later on, now the model is so efficient. You just give the X-ray images on one side, and it will instantaneously be able to say whether the person has a TB or not. Just for your knowledge, 250 X-ray images can be analyzed in just 30 minutes. Half an hour, you have a laptop, you have an X-ray imaging machine, or you just have some digital X-ray images. You give it to the software, it can analyze 250 such X-ray images in just half an hour. So how easy the task has become. So this is one such application of detection of pulmonary TB. And second, quite similar to this, because there is a bacilli which is responsible for such. So again, there is another software which has been created. This work was in collaboration with the civil hospital in Ahmedabad. So there they have taken the sputum of many infected patients, and they have detected the bacilli presence into the samples. They have trained those samples. And now once the samples, any newer sample is taken, given it to the software, it can instantaneously say whether the sample has such a bacilli or not, whether the person is infected with a TB disease or not. So something like this. So this is not only that, you can have many other image processing units. There are many such activities going on. Next, again, you see, which is of importance to the astronomers and astrophysicists. There are many galaxies whose shapes, or whether this is a elliptical galaxy, spiral galaxy, what would be the shape of that galaxy? This classification, this is called image classification. This classification is of utmost importance to them. Now, if you have to do it by hand, so if you have to, go through certain criteria so that you can say, okay, this is an elliptic galaxy, this is a spiral galaxy, or this is a circular galaxy, something like that. But AI can do it very easily. So if you just give it the data or the input image, it can instantaneously analyze and give us a result like whether this is a spiral galaxy, this is an elliptical galaxy, or what kind of galaxy it is. So that's how really AI has benefited us in terms of research. And all these 3 examples which I have shown, they are part of image analysis or image classification. Not only that, it can also give you some kind of predictions. I will show you 2 models of predictive data analysis. For example, you are buying house in a particular area. Now, if you have the data, in which square meter or square feet, how much is the price, then according to your choice, you can also get a predictive price. Okay, that much may be the price in and around which you should find. Not only that, the maps, nowadays AI is heavily used in map technology by Google, and many other private companies are also taking part. They're using artificial intelligence to demarcate certain areas. For example, which one is a forest land, which one is a residential land, what could be the appropriate demarcation, all those things they are doing through AI technology. So actually, now if you talk about in modern research or modern application, where is AI? It is everywhere, almost everywhere. And hopefully in the next 10 years, all sorts of researchers will have at least some application of AI into them. And not only that, AI is also capable of giving you hidden patterns. Suppose you have a data and you do not know what kind of patterns or how set A is related to set B or set A is related to set C of data. What are the hidden patterns? AI is capable of finding out such hidden knowledges or hidden technologies, hidden patterns. Now, let us come to a direct application of AI, which is physics-informed neural networks. Here I will show you 2 to 3 examples, hands-on examples, how we can really have AI, and just to give you a flavor, not going into the technical aspect of it, just to give you a flavor, what kind of problems we can solve. Actually, we can solve many different problems, but I will just select 1 or 2 types of problem and just show what kind of results we may expect out of it. Now, in physics for neural network, already as I said, that suppose you are into a particular country, and suppose you have to buy a new house. And these are some of the prices listed to you. Like if you have 2,600 square feet, you have to pay around, say, $5,50,000. And for other square feet, the prices are indexed here. Now, suppose you are a person who requires square feet of 3,500 square feet or a house of 3,300 square feet, and you do not know really what will be the projected price, then the machine learning really can help you. This is a machine learning aspect of data analysis aspect of machine learning. Now, nowadays, you don't have to really write entire code or entire thing by hand or develop libraries. No, there is a language which is called Python language, normally used for such data analysis in machine learning, and there are libraries into it. For example, the scikit-learn is a tool or a library which you can import into your Python, and you can really, through that, you can analyze or you can build up a model which will be a predictive data analysis. Now, this is basically a very small code. Now, if I ask this question, what will be the predicted price for a house of 3,300 square feet? Now it is giving me an expected price range, 6,28,715.75, dollar. Why? You see, 3,000 square feet, for that I have to pay around 5,65,000. For 3,200, 6,10,000. 3,600, 6,80,000. So if it is 3,300, it should fall somewhere here. And the price should be in between that. So what can we really expect? It is somewhere around 6,28,000. Now, what actually it does? It takes all those data points and fits a linear line through that. These type of problems are known as linear regression problems. Now, you can really plot many other lines. For example, I could have drawn a line like this. All those lines would have a different, suppose straight line, if you say straight line's equation is y is equal to mx plus c. Now, all these different lines will have a different m values and c values, basically the slope and the y-intercept. Now, which will be the best fitted line? That is decided by the algorithm. The best fitted line is for which the errors are minimized. Error means, for example, you see this data point is here, but my algorithm is predicting me a data point somewhere here. So this difference is an error. So likewise, I have a positive error or a negative error for all those data points. Now, if I sum up all those errors, square of the errors, and minimize these particular error, so I have to find a line for which this error is actually minimized. Now, if I draw a line like this, the error will not be minimized. If I draw a line like this, the error will again not be minimized. So this is the best fitted line for which that error is minimized. So that is why this is the linear fit, appropriate linear fit, and through which we can predict the lump sum, in a lump sum way the price of the house. Similarly, there may be classifier problems. Classifier problems means suppose you again have some kind of data. Suppose here I have circular type of data. I have plus type of data. Now this is a very easy classification. You can just draw a decision boundary like that. But sometimes that decision boundary is not very easy to find out. Sometimes your data may be like this. Suppose you have classified like this, and there are positive points like this. Then decision boundary goes like this. So this is a more complex decision boundary. But so by hand or by simple calculations, you cannot find it. So artificial intelligence, or you can say the machine learning algorithms, really help you to find that. Of course, there are algorithms. For example, this is known as the decision boundary. There are also known as the margin boundaries, like how fat should be the decision boundary away from both sides of the data. These type of things are there, which may be calculated, but that technical aspect I would like to skip for now. Now, again, if you take up the solar data, in solar data, what you have, suppose during sun's high activity, the sunspot, there is something called sunspot. Sunspot is basically a small cool region on the surface of the sun. Now, if there are many sunspots, that means the sun is very active. Normally in summer days, you see, NASA gives us alarming calls, the sunspot numbers are increasing. So there is a possibility of geomagnetic storms or something like that, because of which our satellites gets damaged, the grid systems fail. So like that. So if we just take out those data, suppose we have sunspot data on one hand, we have the number density of electrons in the upper atmosphere. Upper atmosphere means 500 kilometer or 1000 kilometer above the Earth's surface. Then can we really correlate those data? Can we really correlate those data? If we just plot it, suppose number density of electrons at 1000 kilometers from the Earth's atmosphere, depending and its variation with the number of sunspot, this should be sunspot. It has been written mistakenly sunpot. It shows data points like this. Once again, I have to find a best fitted line. So the best fitted lines throughout this particular code happens to be this. Now, if somebody asks me, what will be the electron density at a sunspot, say, for example, 130, then I can easily say that, okay, 130 should fall somewhere here. Corresponding to that, this may be the number density of electron, and that must be the, that's how maybe the geomagnetic storm or something, the status of this thing, because this data is linearly fit. Not only that, all these two examples that I have shown, it incidentally happened that the data is linearly fitted. You can also have non-linearly fitted, like data where you may have a quadratic fit or cubic fit or fit of fourth order, fifth order, any higher order. Those are also there. Those algorithms also may be developed using machine learning. Now, let's come to a little modern aspect of machine learning, because as if you remember the very early diagram where we had artificial intelligence as a broad spectrum, within which machine learning is a subset, and within which we have the deep learning. Now let's see what actually is this deep learning. Deep learning depends on certain neural networks. Now neural networks means the people who were working on artificial intelligence at the time, somewhere around 2010, they came up with this conclusion that if the computers have to be accurate or efficient enough, we just cannot develop algorithms. Somehow they have to learn. And the learning process should be quite like the human behavior. So what humans learn, how humans learn? Humans learn through our neurons. What happens, whatever input signal we get, that is processed through a lot of complex neurons, in our brain. And ultimately it gives us an output, and that's how we respond to an input stimuli. So they came up with an idea that if we develop such a neural system for a computer or for a machine, we'll just give them input and take out the output. So in one side, we have input and output. So what is happening in between is training of the data, processing of the data, and somehow they will do all sorts of calculation in between. I am not concerned with that. I'm just concerned with whatever input I have to give and what is expected output. Okay. That's all. So based upon that, they came up with some kind of, neural network structure. I will show that what is a neural network structure, but there are three different types right now. We have feed-forward neural network, convolutional neural network, recurrent neural networks. You don't have to go into the details of it. They are used for many different processes like, for example, FNN is normally helpful for speech recognition, natural language processing. Then CNNs are used for image classification or object classification. And similarly, you also have, once again, the recurrent neural networks for natural language processing and speech recognitions, etc. Now, a simple neural network or a simple neural structure, I may call it as a primitive structure, looks like this. So what is a primitive structure? Primitive cell, those who are into physics or those who are into chemistry, or, we know that there is something called a unit cell. Suppose you have a crystal. Crystal is made up of many small units. We call them the unit cells. And based on many such unit cells, we have the overall crystal. So this is like that. This is a one primitive neuron where you have these many input layers and one output layer. You have basically one output to get based upon 5 inputs. So what actually the neural network will do? They will associate a weight factor on each of these inputs. For example, this is an input whose weight factor is, now suppose if I say there is a society, and into the society I want an output, how the society will judge a particular opinion. Then what are the inputs? Maybe like what could be the type of people remain in the society, how many males or females are in the society, how many children's, like that, what is the gender classification, what is their age classification, what is their what is their type classification, what type of people they are, little conservative mentality, little advanced, or little, how many people are there who are of modern thinking. So these act as input to your data, and based upon that input, how you have to decide like what weight you will provide. For example, if you are giving an opinion which is little age based, for example, suppose whether jeans pant I'm talking about will be appreciated in the society, that will be entirely age based. The people who are little onto the older side, they will not like it. The people who are a little bit towards the middle age or below that, they would love to wear jeans of different colors if you are experimenting with jeans pant. In that case, what you will have to do, you'll have to increase the weight factor of that particular age group and reduce the weight factors of the other input data. So like that, we associate weights and get an output. Now, this is a primitive thing. This is not entirely what really works on a neural network, okay? The real neural network works like this. Here you see, I have an input layer. I also have an output layer, but in between there is something called hidden layers. Now, these hidden layers are really the very important aspect of, or advanced aspect of, neural structure. Why? Because each of these hidden layers, now you can of course, uh, 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 play around with these hidden layers. For example, each of these units are known as the neurons. This is a neuron, this is a neuron. Sometimes people call it as a neuron, sometimes people call it as a unit. So it is just interchangeable words. You don't have to worry much. Input you cannot change because that comes along with your data, how much input you have into the data, or what are the initial things based on which you want to come to a class conclusion. Now, again, conclusive layer, which is the output layer, you want to draw one single conclusion, in which case the output layer will have only one, one neuron. If you want to have multiple conclusions, then you will have many different neurons at the output layers. So these two basically you cannot change. It is problem specific. What you can play around is with the number of hidden layers. So these hidden layers are connected to the input layer on one side and again output layer on the other side. You may have 2 hidden layers, you may have 3 hidden layers, you may have 4 hidden layers. That will depend on the complexity of the problem, how much the problem is complex in nature, or what sort of complexity you are dealing with, how they have to learn, how they have to be trained, like that. I will show you one particular result where these neurons actually play a role. So let us go into that. This is a simple classification or is a differentiation between machine learning and deep learning. I will, yeah, I would just like to skip this particular part so that, or maybe we can discuss it very briefly, machine learning and deep learning. Machine learning is something where you have these statistical algorithms are into application, and deep learning is something where you have the artificial neural networks in application. In machine learning, typically we do not go for these neural network structures. Deep learning is entirely based on these neural network structures. Then machine learning typically works on smaller amount of data set because it is mostly algorithm based. It has to do some calculations on a linear scale. But deep learning, it can really handle, big data nowadays. It can handle low level task. It can handle, little complex task, and it takes less time to train the model. Of course, deep learning will take more time because uh, it is really complex by nature. Then a model is created by relevant feature. Feature is a feature vector. Basically, it's talking about. Let's not worry about this. And here, the relevant feature vector are not actually mathematical expression. They are automatically extracted from the images or the data. So in deep learning, you don't have to really specify any kind of vector or any kind of functions. Provided you give it, I mean, the appropriate input, it automatically takes it into consideration. It is less complex and easy to interpret the results here. It is a little bit more complex. It is mostly CPU based. This is mostly GPU based, where we have graphical processing unit into actions, but not necessary that for running a deep learning program, you have to have a GPU. No, you can also run it on CPU, but nowadays people are saying like GPUs are more computationally efficient over CPUs and cost effective also. So that is why NVIDIA and all, they are really coming with a lot of GPUs, and also they provide courses on these deep learnings. You can also see across this internet. Now let us come to a very interesting physics problem. There is a famous saying, in Hindi. It's called "लौट के बुद्धू घर को आए." Lord ke buddhu ghar ko aaye basically means that the person who belongs to a house, for some reason he was angry with the people. He went out, and then eventually towards the end of the evening, he had to come to the same house only. So because I belong to this physics community, somehow going in and around, I have to come back to a physics problem only. So let us consider a physics problem. I understand there are people from diverse background. So do not worry at all about what I have written on the slides. Just mark my words or listen to my words. That would be enough. Okay. You do not have to really be bothered about the differential equations. What is I, what is L, what is R? No, entirely not. Just mark my words. So let us consider a dissipative system. Dissipative systems are always, in our proximities. Anything give to a system eventually dissipates. For example, if you talk about boiling a glass of water, talk about making coffee, if you leave onto itself, the heat will be dissipated. Eventually it will come to it will be cooled down. You talk about a swing, swing already, this type of swings. If you give it a force on one side, what will happen? It will go, it will come back, it will go, it will come back, but eventually it will come back to the rest. So this is also a dissipative system. So dissipative systems are basically systems from which the energy is being drained away by interaction with the environment, and it comes automatically to a rest or standstill condition. Now let us consider such dissipative system. You can see in terms of an electronic circuit or a mechanical equivalent is like this. Mechanical equivalent means, suppose you consider a spring and to which a mass is attached, and you just stretch this mass and release it. And suppose this whole system is drowned inside this liquid. So this liquid will act as a dissipative system or dissipator to the energies. So this mass will oscillate to and fro and eventually will come to a rest. An analog of this in electronic circuit is an LCR circuit. So we have an inductance, we have a capacitor. Capacitor is something which you have in your fan. And so this stores electrical energy, this stores magnetic energy. Now there is an oscillation between electric and magnetic energy. However, the system dissipates throughout this resistance, and eventually there will be heat generated and the entire energy will be lost, and the system will come to a standstill after some time once this switch is closed. If you just press on this switch, this circuit will be complete and current will go through this circuit. Suppose the initial voltage of this capacitor be V0, and so a current will be driven into this circuit. Now we have to see with respect to time how this current is changing. So that is why we can frame a differential equation in which we have current as the dependent variable and time as the independent variable. Why this is independent variable? Because time really do not depend on anything. Time just moves according to itself. You start the experiment at time t equal to 0, it will move on to itself and say it will stop after several seconds or several hours, like that. But based upon the time, one quantity will vary, that is called the current. And rest everything else is fixed for me. I have a set values of L, set values of R, set values of C. By the way, L, R, and C are known as the inductance, resistance, and the capacitance of this circuit. Now, this is a differential equation, which is second order differential equation. So we definitely should have two initial conditions. One is set by at time t equal to 0, just when you started this experiment, then current in the circuit was 0. And at the same time, the capacitor was fully charged. So you had this condition like L di by dt should be equal to V0. So these two conditions should be satisfied so that this equation is true. Now there are three responses how current varies with time. That is called underdamped, critically damped, and overdamped. These are really not important in this case. So just forget about it. Just right now understand that this is a condition which gives us something called underdamped response. Okay. Now you see this equation is true for this electronic circuit. Now, since we have also shown a mechanical analog as a spring mass system which is attached to a water body, what will be that kind of an equation for this system? This is given by this equation. This is also dissipative system equation, second order linear differential equation. You can also solve this. Now, typical way of solving differential equation is just attacking this problem directly through something called Runge-Kutta method. This is called Runge-Kutta method. It's a fourth order accurate method. Those who are not into computational things, you don't have to bother much. This is just a method, a name of a method through which you can solve a differential equation. There are many other methods like finite differencing there, finite volume methods are there, spectral methods are there. So either through any of this method you can solve. And this is basically a Python code which we have written. It's a small code, so I could show you here. And this is how the response comes up. Okay, I have not written here, or this is basically the current in ampere. So this is how the current moves. You see, the blue line is for the numerical evolution, and this dashed lines is for analytical evaluation. So this is the analytical expression. Analytical expression means if you solve it by hand, this is the expression you should get for underdamped oscillation. Okay, and we see that these two graphs are matching exactly. So my numerical simulation and analytical results are matching with each other. So they're perfectly in coherence with each other. Now, can I give this problem to a neural network? And can it solve it for me? So in this case, you see, I have given this differential equation I have solved. So in neural network, I will not give this differential equation. I will not tell the neural network at all about this particular equation. I'll not give this neural network a hint of this differential equation. But can it solve? The answer is yes. So that is why it is the beauty of neural network. You see, if we design this problem into a neural network, you can really see that we have only one input, time, because only one independent variable over here, that is time, which flows as it wishes, and one output, that is the current. So that is why we have only one neuron in the input and one neuron in the output, in the form of time and in the form of current. So this is output, this is input. And in between, I have constructed a layer of, which is called hidden layer, layers of 10 neurons each. There are two hidden layers with 10 neurons each. If such a problem is solved, I have some time, yes. Yeah. So if such a problem is solved, of course, you nowadays don't have to write the entire algorithm into your Python. There are libraries, Python libraries, basically TensorFlow, PyTorch, etc., which will help you to do that. Then this is how actually the algorithm looks like. What I have to do, I have to construct a neural network, give input as time, and extract the current. Through this current, whatever will be coming out of this neural network, I'll have to construct two more things. One is the second order derivative of this current, one is the first order derivative of this current. Now, these three things combined together should comply three equations. One is this, one is this, one is this. If they do not comply, then it will give us a loss function. Let us understand that. Now, this is an equation which the circuit should satisfy. That means this entire left-hand side for a particular value of L, R, and C should give you a result called 0 if your current expression is correct, isn't it? So whenever we give the time and whatever values of current here I get, at each of that time, I will compare whether this left-hand side is 0 or not. So there is a comparison between this equation with 0. Actually, I should not write hopefully 0 equal to 0 over here. With this expression, with 0. If that is equal to 0, no problem. There is no loss. If for the first instance, this is not 0, then I coin this term as a loss 2. This is a loss. At the same time, if the first order derivative of current is not V naught by L for time t equal to 0, then this is loss 3. And if the current at time t equal to 0 is not 0, then this is loss 3. So these are basically from the initial conditions. Initial conditions. Okay. Combining these three losses, I can construct a total loss, which is called loss 1, loss 2 plus loss 3. This total loss is the basis of the training model. So once I get the first output, I will say, no, 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 you have loss into this. So you rectify it once, you run it for one more loop and see, you adjust your weight factors into the neurons and get me a result such that this loss is minimized. So what this neural network will do, it will continuously one after another, it will run it for several loops and it will try to minimize. If the losses are on increasing order, it will not go into that fashion. It will adjust the weight factors. It will go on minimizing these losses and eventually come to a state when these losses are minimized enough. So you have to give really an optimization. This is called an optimization algorithm, through which it determines whether the losses have been minimized enough or not. Once this loss is minimized, say for example, loss is almost very negligible, 10 to the power minus 10 minus 11 or minus 15 order, or even maybe less than that or a little higher than that, then it can say, okay, your program has been saturated. You can come out of the loop. Your model has been trained and here is your result. So how good is my result? Let us see. This is once again the analytic expression. You already have seen 2 slides back. And here the red graph basically is a result from the neural network. The blue graph is a result of this analytical function. So you can see the graph matched well in this particular segment. But somewhere in this particular segment, it is following the trend of the data, but not an exact match. So in this case, I have used a 128 neurons. 128 neurons I have used. That means what? Here I have shown you this picture of 10 neurons here and 10 neurons here. 128 means instead of 10, you will use 128 neurons over here. and 128 neurons over here. That will make this diagram really very big. I cannot fit it into this, slide. So that's why I have shown this with 10 neurons just, but I will also show you what happens with 10 neuron in the result. Let us just see. Let us just decrease the number of neurons to 10 and also increase the number of neurons to say 256. Let's see how the results vary. So in this case, you can see with 10 neurons, the result matched very nicely here up to this particular aspect. But wherever there is this nonlinearity coming, in this particular aspect, this difference is very high and not very appropriate. So once you increase it to 56, you see it's very nicely matching. Although there is a very small, disagreement in this side or very minute disagreement in this side, but to a fair degree of accuracy, you can say this is matching. So like that, just by varying this number of neurons and all, you can construct your model, or you can really come to a solution of such a system. Now, you may ask me a question like, if I already have a numerical solution or an analytical solution, what is the requirement that I should deploy a neural network? Yes, in this case, I already have the methods known. But what about some more complex problems? In which case, I may not have an appropriate method which will solve that equation or which will solve that particular thing. In that case, what I'll have to do, I'll have to rely on the deep neural networks or deep learning methods. So they can come up with a solution and they can really give us some of the, answers to queries or the complexities. So that's all basically I had. So I would like to conclude my talk with these many, small conclusions. Artificial intelligence is a broad term that includes machine learning and deep learning within it. It incorporates a broad spectrum of possible applications in many different fields. So really, the applied fields are so one really cannot say that he's an expert of AI or something in all fields. It's very difficult, I guess, because everybody has their own perspective into the field. Then with the help of machine learning and deep learning, we can solve many complex problems and find complex patterns into in a complex systems. The modern research scenario seems to be highly dependent on AI, and I believe in next 10 years, it will be entirely dependent on AI, or mostly to fair degree of, percentage, it will be dependent on AI technologies. And again, a simple electronic circuit has been demonstrated for a dissipative system. Just to showcase you or give you a feel of what could be physics-informed neural networks. And there is also a possibility of, inverse physics-informed neural network. You can understand this particular thing. This one. In inverse spin, in this previous problem, I already gave these values, L, C, and R. Now, instead, if you have a response function, through that, you can guess these values, L, C, and R. So that is also a very interesting thing. Suppose sometimes you do not know the parameters of a system. You can really, and you have the response of a system. So through analysis of that, you can get back the parameters of the system. All right. So that's all basically I had for today for this FTP. These are some of the references which I have followed. There are many more references. In particular, I'd like to highlight these two books, this one and this one. And the Geeks for Geeks is really a good platform through which you can get many codes and all if you wish to learn more. And yeah, there are many other videos across internet and YouTube and all. So you can really go into that. And I would like to conclude with this particular statement, like artificial intelligence is not a substitute for human intelligence. It is a tool to amplify human creativity and ingenuity. So I really like this statement actually, because many a times we are afraid of losing jobs because of AI, and these are often in news. I don't think that we will lose job. Yes, certain sectors we will cut jobs, but there will be newer and newer jobs required also. For example, there will be requirement of people who knows ChatGPT, who knows how to apply, artificial intelligence technology, who knows how to use such things in order to get or interpret some of the results. So a human intervention will always be required for analyzing the results or to implement the results. It is basically to minimize error. AI technology is basically to minimize the error which is normally caused by humans, or to visualize some of the hidden patterns which is otherwise not perceivable in human mind. So with this, I would like to end or conclude, but here is a so thank you, basically. And this is a Google form, which I already have shared with the organizers. Hopefully they will give you. There are 10 questions, fun questions you can really attempt. And instantaneously, we'll also get the grades, how much you have, obtained out of 10. This is completely based on my this talk. Uh, so you can just try it for fun activities. Yes, there could have been much more answers. I just thought 10 questions will be enough. You can really attempt more. Thank you so much. Over to the organizers.
Thank you, sir. Thank you very much. It was such a wonderful presentation, sir. We are so
Thank you so
grateful
much.
and thankful to you for sharing your valuable time in delivering this talk, sir. We would like to
Thank you so
listen to
much.
you more in future, sir.
Thank you. Thank you so much.
Sir,
Yeah, actually,
currently,
actually, I would like to thank you for giving me this opportunity and share, on this beautiful topic. And that's what I say. Yeah, I congratulate you for, taking this challenge of bringing up this AI into in FDP. I don't think anybody has done it yet. Yeah.
thank you, sir. Currently, there are no questions, but from my side, there is one question, sir.
Yeah, sure, please.
Sir, a few months back,
Hmm.
in that Meta AI in WhatsApp,
Hmm.
I've typed a question on group theory.
Hmm.
Yeah, and I already had the answer, and the answer that came from Meta AI was wrong.
Oh,
Yeah. So I
okay.
told the Meta AI that your answer is wrong.
Correct,
Then he gave
correct.
me another answer.
Okay.
Then I told again, I think the answer should be this.
Yes.
And he said, oh, yeah, you're right. The answer is this. So,
Okay.
sir, does it mean that the next time I ask Meta AI, that will give me the correct answer or it will not update itself?
It should give you the correct answer, because the moment that is why you see nowadays in Facebook, I don't know. I just have gone through Facebook, and sometimes advertisements come. So one such advertisement I have seen, it's a job opening where you have to train the AI. Train the AI means, suppose are you proficient in mathematics? It was only on mathematics basically, and they were looking for somebody who was doing PhD or some graduate students who are a little proficient in mathematics and maths background students, such that they could train up the AI. Train up AI means, like as you have said, for example, whatever answer you were expecting, you are not getting it. So AI was giving you a wrong answer. So somebody has to be there who will tell, okay, no, this is wrong and this is the right answer, so that the AI technologies or AI algorithm learns. So like that, the more people give that, okay, this is correct, this is correct, this is correct. So it will update itself. The algorithm will update itself. And next time, once you ask something, suppose you change the parameters to some sort, and then reload this question. Now it is expected that you will get the correct answer, because you already have said that, yeah, this is a correct thing. So that's how you somehow somebody has to be there who will be training the AI every time for the correct answers. There, that's how it will learn, and it will give us the expected result. Yes.
Sir, there is one question from Ananta Goge, sir.
Hmm.
He asked, can we say to some extent that AI is the assembling tool of various softwares available at present?
Yeah, yes, hopefully various softwares. Yes, many of the softwares nowadays, if you see Adobe Reader, previously, just I think it has started for about 1 year or so, not even 1 year. I have been seeing it, that there is an AI assistant. There is a small thing, a small toolbar called AI assistant. So yeah, all these softwares are now trying to embed the AI algorithms into their routines for such implementations. That's true. I believe that's true. Yes. In future, we will see more into that.
Thank you, sir. Dear participants, if you have any question, please post it or you can just unmute yourself and ask question to Rakesh, sir. Sir, I think then there are no more questions. So thank you once again. And on behalf of the team, we would like to felicitate you, sir, with some of our mementos. Pathoda, can you please felicitate, sir?
Okay. Rakesh sir, please unmute yourself. We cannot hear you actually.
Okay. Yeah. Somehow I got muted. Yeah. Sorry. Am I audible now?
Yeah, yes, you are audible, sir.
Okay.
Pathoda, kindly share your screen. It was a nice talk, sir.
Thank
you
you so
for
much.
yeah.
Thank you so
It
much.
was
Thank
very
you so much.
popular and it has very interesting discussion.
Thank you. I actually tried not to go into the technicalities because of these diverse, participants. Yes.
Yeah, that is very good.
Okay. Okay. Thank you so much. It is so
Can you see it,
nice.
sir? Can you see it?
Yes, I can see it. Yes. Thank you so much. Thank you so much. Yes. It's very nice.
Thank you, sir. I think we can leave now, sir.
Okay. Thank you so
Have
much.
a lovely evening,
Yes.
sir. Good evening.
Thank you. Yeah.
Thank
It's
you,
a
sir.
great
I
opportunity
request
for
the
me to.
participants kindly to fill up the Google form and as well as please fill up the quiz, the Google form that has been provided by Rakesh sir.